Good morning, all. Welcome back to Fecam's unique Histology review series. This video is brought to you by the academic and editorial boards of the Federation of Catholic Medical and Dental Students, Fecam's unique chapter. My name is Zuguchukwu Victor, a 500 level medical student of the College of Medicine, University of Nigeria Teaching Hospital, Itzkwazala, Enugu State. Please do not forget to like our videos and subscribe to our channel, as it will encourage us to make more educational content like this. Thank you. So today we'll be looking at the histology of accessory organs of digestion. Now, the major accessory organs of digestion are the liver, the pancreas, and the gallbladder. So let's read out the notes on the liver. So the reasons for identifying the liver on histology is the first one is the hepatocytes, second one is fenestrated sinusoids, third one is the portal triad, fourth one is the central vein. The functions of the liver is drug metabolism, albumin production, biosynthesis of vitamin D. The development of the liver is from the hepatic board or the hepatic diverticulum. The weight of the liver in adults is 1.5 kg in males and 1.3 kg in females. The location of the liver is the abdominal cavity. Then the pathologies involving the liver includes liver cirrhosis, hepatitis. Now, how do you identify the liver when it is presented to you? So the liver is organized in structural units, which is called the hepatic lobules. And the hepatic lobules, they possess a distinct hexagonal shape that is peculiar to it. And then at the center of the hexagon, you find the central vein of the liver. And then at the edges of the hexagon, you find the portal triad. Now let's zoom in into this image. Okay, so this image is already labeled. You can appreciate the central vein, which is this. And then you can also appreciate the hexagonal outline of the hepatic lobule, which is the structural unit of the liver. Now, you can also appreciate irregular cords of cells radiating away from the central vein. So these irregular cords of cells represent the hepatocytes. So they are the major cells you find in the liver. And then you can also appreciate tiny spaces in between the irregular cords of cells. These tiny spaces. So those represent the fenestrated sinusoids. So fenestrated. So this fenestrated sinusoid, they contain some macrophages, Kupffer cells. So Kupffer cells are the macrophages of the liver. So then at the edges, you see the portal tract. So the portal tract is this, or the portal triad. This one, the one in blue, represents a branch of the hepatic portal vein. The one in green represents a branch of the interlobular bile duct. And then the one in red represents a branch of the hepatic artery. So you can also appreciate the hexagonal outline here. And then this one too. See that? And then you can also appreciate the central vein, which is prominent. So that is it for the liver. So let's look at other slides of the liver. So look at this one too. You can also appreciate the hexagonal outline, though it's not really very clear here. But then you can appreciate the central vein. See that? And then you can appreciate irregular cuts of cells radiating away from the center with the presence of fenestrated sinusoids. Then look at the edges. You can appreciate the portal triad, though it's not really distinct here. Then this one too. Now, in this image, you can also appreciate the hexagonal outline. This is not a perfect hexagon though, but it serves the purpose. And you can also appreciate the central vein, and then the irregular cuts of cells radiating away from the center. Same thing here, central vein. Appreciate this hexagonal outline. Same thing here, central vein, then hepatic, the portal triad. So the slide of the liver is quite easy to identify on histology. Now look at this one also. The central vein, then the irregular cuts of cells radiating away from the center. Then the faint hexagonal outline. It's not really clear here. So this one too. Central vein, irregular cuts of cells radiating away from the center. Then fenestrated sinusoids. So this one is the portal triad. Now, the image, let's read the notes. The image on the right further shows the 3 zones of the liver with a strong correlation with liver metabolism. So this particular aspect is talking about the Rappaport zones of the liver. So the Rappaport zones of the liver is a kind of structural lobule of the liver that represents a segment of the liver which is supplied by a single hepatic arteriole. So it's a kind of diamond shaped, and the long axis of the diamond is connected at the ends by 2 central veins. So let's go back to the previous image and illustrate this. So something like this. Let's see these two central veins, this one and this one. So it looks like this. See how the thing runs. So the zone 1 is the one closest to the central arteriole. Zone 2 is the one next to zone 1. Then zone 1 is the one closest to the central vein. Zone 2 is the next zone after zone 1. Then zone 3 is the one that is closest to the hepatic arteriole. So this is how it looks, diamond shaped. So zone 1 is the zone around the central vein, like this. This area is zone 1, then zone 2 is the next zone, then zone 3 is the zone that is close to the central arteriole. So see the zones here again. Zone 3 is close to the central vein. Zone 2 is the next zone. Then zone 1 is the zone closest to, I made a mistake in the explanation. So zone 1 is close to the portal tract, portal triad. Then zone 3 is close to the central vein. So take note of that correction. Then zone 2 is the zone between zone 1 and zone 3. So zone 1 is the most sensitive. Zone 1 is the least sensitive to ischemic damage because it's close to the hepatic arteriole. Then zone 3 is the most sensitive to ischemic damage because it is furthest away from the hepatic arteriole. So the Rappaport zone is just a kind of unit, a structural unit of the liver that correlates with liver metabolism. So that's it about the liver and the Rappaport zones. So zone 1 being closest to the portal triad, zone 2 the intermediate zone, and then zone 3 being closest to the central vein. So that's it about the liver. Now the next one that we are going to look at is the pancreas. So let's read the side notes. So the reasons for identifying the pancreas and the islets of Langerhans and the pancreatic acinar. Then the length of the pancreas is about 15 cm. The weight is about 90 grams. The development is from the ventral and the dorsal pancreatic board. The pathology involving the pancreas include acute pancreatitis, pancreatic CA. Then depending on the pointed structure, the identification can change thus: islets of Langerhans, region alpha and beta cells, function alpha cells produce glucagon, beta cells produce insulin, or the identification can be pancreatic acinar, reason pure serous acinar, function secretion of alkaline enzyme rich food. So what this thing basically means is that in the histology steeplechase exams in UNTH College of Medicine, the identification that you are meant to give will depend on the part of the slide that was pointed to. So assuming the arrow was pointing to this, something like this, your reason for ID will be pancreatic acinar. Then if it were pointing to this, so this is the most colored area, the more colored area, and then this one is the poorly stained area, which represents the islets of Langerhans, and the deeply staining area, which represents the pancreatic acinar, the purely serous acinar. So the one that is pointed in exam will depend the ID and the reason that you give. So that's what this whole thing is about. The lower side notes. So now how do you identify the pancreas? So the pancreas is a mixed gland. It is both an exocrine and endocrine gland. So exocrine in the sense that it releases its secretion into ducts, and then endocrine in that it releases its secretions directly into blood vessels. So the endocrine part is the islets of Langerhans, which contains some group of cells, alpha cells, beta cells, and delta cells, while the endocrine part, the exocrine part represents the pancreatic acinar. So on the pancreatic acinar, they release serous secretions, just like you see in the parotid gland. So they release serous secretions, hence they stain deeply. They take up hematoxylin and eosin stain very well. Then the islets of Langerhans will appear as poorly staining patches. Areas like this, represent the islets of Langerhans. So these things are like ducts, blood vessels found within the pancreas. So the pancreas is arranged in kind of lobules with interlobular ducts connecting the lobules and so on. And then you find patches of islets of Langerhans. Now let's look at other images. So look at this one. The pancreatic acinar stains very well. Then you see discolored patches of cells. So this represents the endocrine part of the pancreas. The endocrine part, that's the islets. They don't stain well. While the exocrine part, which is the pancreatic acinar, they stain very well due to the secretions, the serous secretion that they release. So the endocrine part, which is the islet, does not stain well. Same thing here. You can appreciate it. This is the polystaining patch. Look at this. The islets of Langerhans. And then this represents the pancreatic acinar. So look at how well stained it looks. And this one looks polystained and a bit irregular. Now, some students can mistake the parotid gland for the pancreas because of their similar features. So let's differentiate between them. So if you come to the parotid gland contains serous acini and a very few mucous acini. So it is predominantly serous acini. And remember, the serous acini, which is this area, stains very well because of the kind of secretion it releases. While the mucous acini, look at this, something like this. Mucous acini, they don't take up the stain, the hematoxylin and eosin stain, so they appear pale. So they are not like the irregular discolored patch on the pancreas. So look at this. You can also appreciate the orderly arrangement of the cells into a kind of an acinar. See that? Surrounding a central space. So they are like this. So they don't take up the stain due to the kind of secretion. The mucin contains complex carbohydrates that don't stain well. So look at this one too. This one represents the parotid mucous acini. It doesn't take up the stain. Look at the way the cells are arranged in the acini. Then a kind of central space. So then this one represents the pure serous acini. So the parotid gland contains serous acini predominantly. So refer back to the earlier videos on the parotid glands, salivary glands, for a better understanding of the parotid glands. So this is the mucous acini. See the orderly arrangement of the cells in a form of acini. So this represents these small black dots represents this small purple dot represents the nuclei of the cells of the acini, the mucous acini. Same thing here. Notice the central space. Here, and then the purely serous acini. So that's it for the parotid gland. So let's go back. So I hope this clarification is enough to make the difference between the parotid gland and the pancreas clear. So this another image. So here, I think this is the interlobular duct being pointed at. Then this is discolored patch, irregular discolored patch. It's not arranged like the mucous acini in the parotid gland. You can't appreciate the central space and then the arrangement of the cells around the acini, within the acini. So this one is like a discolored patch. Now let's read the side note. Sometimes the arrow on the brighter colored patch, the arrow is on the brighter colored patch, and then you're asked to identify the pointed structure. So if it is on the discolored patch, just like I've said before, your ID will be islets of Langerhans. Reason for identification will be presence of alpha and beta cells. Functions: alpha cells produce glucagon, beta cells produces insulin, and delta cells produces somatostatin. So that's it, somatostatin. Now, the next accessory organ of digestion is the gallbladder. So let's read the side notes. The reasons for identifying the gallbladder includes the irregular mucosal folds lined by tall, beautiful, simple columnar epithelium, the functions, storage and concentration of bile, secretion and secretion of mucous contents of bile. Development is from the pars cystica of the hepatic board. The pathology, cholecystitis and cholelithiasis. Stimulator is cholecystokinin. Capacity is 50 ml. Then anatomical location is the right lobe of the liver. The lookalike is the small intestine. So, in the histology exams in various schools, if you are presented with the slide of the gallbladder, always ensure you name it in full, because we have another bladder within the human body, which is the urinary bladder. Same thing with when you are presented with the slide of the urinary bladder, always ensure you name it in full. Urinary bladder, if it is the gallbladder that is presented, don't just end at bladder, name it in full. Urinary bladder, gall bladder, and so on and so forth. So always try and ensure you name it full. So the gallbladder kind of looks like the small intestine, but the differences are many. The first difference is the mucosal fold. So the mucosal fold in the gallbladder is so irregular, and you can't find the finger-like projections. Remember the villi in the small intestine. So if you haven't seen how the villi looks like, I recommend you go back and watch our earlier videos on the small intestine. So look at the irregular mucosal folds. You see that? And then the simple columnar epithelium, though you might not really be able to appreciate that here in this image. Then also the gallbladder doesn't have submucosa, so you can't appreciate the submucosa. Also, the next difference is that the gallbladder is covered by a fibromuscular coat, so you won't find a distinct. So these are like bundles of muscles which are disordered, so you can't really find the well patterned arrangements of the muscle layer, inner, circular, and outer longitudinal, as seen in the small intestine. So you see the muscle suspended in fibromuscular stroma. So they call it the fibromuscular coat, which covers the gallbladder. So this is just like the fibromuscular coat, contains both muscles and then connective tissues. So this is specific for the appearance of the gallbladder. So this is how the gallbladder looks. Note the irregular mucosal folds, which is the most important thing. Absence of submucosa. So there is no submucosa here. All these folds are mucosal folds. And then the next layer, immediately after the mucosal folds, is the fibromuscular coat. So that's it about the gallbladder. So I hope you got all the explanations. This is where we are going to stop for this lecture. Drop your questions and comments in the comment section. Thanks for watching. We'll see you again in the next lecture. Thank you.